Alright, so this video is meant for my geometry students. We have a test over chapter 10 on Monday, and I've made a sections 1 through 3 quiz review. So this is going to be our 10 through 4, and this is the review for the test. Alright, so this should say test review. Okay. We're going to go through several problems involving angles, segments, and then some equations of circles. If it gets to be too long, I will cut this video in half and create 2 videos. Alright, so here's the first set of questions. We're going to do find the value of each variable, and it's going to involve angles. So on this problem, we have 4 variables to find: A, B, C, and D. Okay, so let's talk about each one. First, B. B is that angle right there. It's on the circle and it intercepts that arc. So B, angle B, I'm sorry. B represents a angle that is on the circle. So it's going to be 1/2 its intercepted arc of 156. So B is going to be half of 156, which is 78. So there's B. Okay. D. Notice D opens up to this arc right here. Now, according to the picture, we don't have the measure, but we do, because guess what this angle is right here? That's the central angle. The measure of the central angle is equal to the measure of the arc. So that arc is 108. So to find D, let's see, D is on the circle as well. To find D, we're going to take half of 108. Again, it's another circle. This is not an on the circle. This is an inscribed angle. I'm sorry, inscribed angle. But again, remember, inscribed means you're on the circle as well. It's still half the arc. And half of 108 is going to be 54. So now we have B and we have D. So B, I'll fill in with 78. D was 54. Well, now to find A right here, A, these 3 angles, A, B, and D, all create this straight line. If we trace this line, so to find A, we use the idea that they're supplementary. A plus 78 plus 54 should equal 180. Supplementary angles, or angle addition. So A is 78 plus 54. That's 130. That's 132. So A plus 132 equals 180, and we'll subtract 132 from both sides. A is 48. So now to find C, which is this arc, we have its angle. Its angle is A. A is on the circle. So A is going to be equal to 1/2 of C. Well, we know what A is. A is 48. Times 2, times 2, 96 is C. And there's our 4 variables here. So in this problem, we have a couple angles that are on the circle, and then this inscribed angle D. Okay, all half the measure of the arc. Okay, so here's another really good problem. These are all really good problems because they're not easy, right? They're not simple. But we'd rather do the hard ones now than the hard ones later. A is on an inscribed angle. Inscribed angle. It's on the circle, right? So if we trace A, it intercepts this arc, 144. So A is equal to half of its arc of 144. So A is going to be equal to 72. B is in the same situation. B is right here. Let's use blue. Trace B, it intercepts this arc. B is again another inscribed angle. So to find B, we're going to take half of 48. That's going to be 24. And now C is the tricky one, because C is here. C is an interior angle. So it's going to be half the sum. But notice that C, we would need this arc and its vertical arc, which we do not have. Let's call this angle x. We know x's arcs are 144 and 48. Let's find them first. X equals half the sum of its arc, 144, plus its vertical angle's arc, 148. And when you do this in your calculator, 144 plus 48 is 192, and half of 192 is 96. X is 96. That's that angle right there. So to find C, we're going to take 180 minus 96, because C and X are supplementary. We use this supplementary idea. So we get C is 84. And there's our measure for these three angles. So here we have an inscribed angle, and then an interior angle. Okay, very good. Again, not the easiest problems, but good problems. Okay, and here's the last angle problem we'll talk about. In this one, you're not really finding an angle, you're finding x. But x is involved with this angle right here. This angle is an exterior angle. So we need to do half of a difference. Now, the angle here, we need arc here, which is x, and then we need this arc right here. Well, I don't know what that is. Well, we know this one, though. This is 140, and we know that that one is x. So to find this missing arc, let's call this one y. To find y, we need to take the whole circle, 360. Subtract 140 and subtract x. Subtract the two arcs that they tell us about. 360 minus 140 is 220. And the minus x has to remain the minus x. And here is the measure of that arc, 220 minus x. And now we can find x. Forget about y now. Who cares about y? We have our two arcs. So exterior angle is half the difference. So 38, the angle, is equal to half the difference of 220 minus x minus x. 220 minus x minus that x. 38 equals half of this right here. These parentheses can just drop because there's nothing right there. So it's just 220 minus x, and that's 220 minus 2x. Now I look at this problem and I say, hey, these numbers are both even. Go ahead and take half of them. 38 equals 110 minus x. And now we just solve. Subtract 110, sorry. Negative 72 equals negative x, and divide by negative 1. 72 equals x. So 72 is x. This right here, again, this is an extension of the problem. 220 minus 72 is 148. And if we add up all three arcs, 140 plus 148 plus 72, you're going to get 360, which is the circle. Okay, so x is 72. So this was an exterior angle problem, but then it required some more information with arcs. So again, understand what you need in the problem. Find that first before you actually figure out what you really want to find. In this case, x. Okay, so there's the angle problems. Okay, here's our next problem. Next set of problems. Find the value of the variable, and these are segment length problems this time. Okay, so here's my picture. And in this picture, we need to first identify the situation. This is the two chords situation. Two chords. So remember, chords is all about parts, right? All about parts. So in this problem, it's going to be x times x plus 11, that's this chord, equals 10 times 8, that's this chord. And again, it's all about parts. And here we go, we get x squared plus 11x equals 80, and uh-oh, quadratic formula. Subtract 80 from both sides. And here's where we have to use the quadratic formula. The quadratic formula, remember, write this down. If you have an equation ax squared plus bx plus c equals 0, the quadratic formula says it's the opposite of b plus or minus the square root. of b squared minus 4ac all over 2a. Okay? So, in this problem, I want three numbers. Opposite of b is negative 11. We'll do the squared on the side, and 2 times a is 2 times 1, which is 2. And to do the b squared minus 4ac, I'm going to take 11 squared minus 4 times 1 times negative 80. And when you do this, you get 441. That's the number that goes in there, 441. But now I want to quickly figure out what the square root of 441 is. I don't want that there. So square root of 441, and it comes out to be a nice number of 21. So this is now 21. So now we do our two problems. X equals negative 11 plus 21 over 2. X equals negative 11 minus 21 over 2. And we get 10 over 2, which is 5. And we get negative 32 over 2, which is negative 16. Right? Here are two answers that we get. X cannot be a negative length, so we keep the positive one and cross this off. So X is 5 in this problem. Need to be good with the quadratic formula. Okay, our second problem here, and if I look at the situation, I'm looking at the 2 secants case. 2 secants, secant is part and whole. So we have to think of the part and the whole. Alright, so if I take a look at the top secant with x, 10 is the outside part times the whole, which is going to be x plus 10. Got to add those together. The bottom, 12 is the outside part, and then the entire thing is 12 plus 25, which is 37. And that's the whole, part and whole. So we distribute the 10, 10x plus 100 equals 12 times 37, which is 444. Subtract 100. 10x equals 344 and divide by 10. And that's going to give you 34.4. No quadratic formula necessary. You should be very thankful when you see a situation like this. 2 secants case. And finally, we take a look at this problem here, last segment problem, and I look and I see this is a secant tangent problem. Secant is part and whole, and tangent, remember, it is squared. So when I set up my equation, my secant, my outside part, is x. My entire segment is x plus 30. The tangent is 20, and we're going to square it. So I distribute my x squared plus 30x equals, and 20 squared is 400. I need to move the 400 over because this is a quadratic formula problem, so I subtract it. And now, here's my A, B, and C. X equals opposite of B plus or minus the square root. I'm going to do it on the side. All over 2a, 2 times 1, which is 2. My b squared minus 4ac is 30 squared minus 4 times 1 times negative 400. And that comes out to be 2500 inside that square root. And now I want to take the square root of that to see if it comes out to be something nice and even, and I think it does. Oh, happy day, it's 50. No square root at all. So now I break it up into two problems. X equals the opposite of 30 plus 50 over 2. And x equals the opposite of 30 minus 50 over 2. We will get 20 over 2, which is 10, and we'll get negative 80 over 2, which is negative 40. X is a length, cannot be negative, so it is 10. And there's the length of x in this problem. So again, understand what situation you're working with. Do those note cards and really study them. Very good. Okay. Last set of problems come. Okay, 2 circle problems to do. Here's the first problem. Here's the equation of a circle. Graph the circle. Okay. Well, we have this equation, x minus 1 squared plus y minus 4 squared equals 16. So remember, the center is opposite of these. 1, 4. So my graph, 1, 4. Okay, so there's my center. Then the radius is going to be the square root of 16, and that's 4. So I'm going to count 4 up, down, left, right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And up here I didn't give enough room, sorry. 1, 2, 3, 4. And here comes my circle. Alright, and that's the equation of the circle, graphed. Alright, so now the question is, can you tell me which of these points is on the circle, in the interior, or in the exterior? So let's graph these points and see what we get. So 3, 6. 3, 6 is right here. I'm going to say that's in the interior. Negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3. Right there. I'm going to say it's on the exterior. Outside the circle, right? And then negative 1, 3. Negative 1, 3. And again, I'm going to say negative 1, 3 is in the interior. Okay? So that's what we're talking about when we talk about interior, exterior on the circle. Now, if it was really close to the circle, I might consider that it's on the circle, but none of these are really close. Okay? So there's how we graph and then determine if a point is in the interior, exterior, or on the circle. Okay. All right, last problem coming. Okay, so here's a problem that you're definitely going to see that we really not have gone over yet, but I do give you a hint on the test because I know we haven't gone over it. But here's the situation. Find the equation of the circle. I give you the center at negative 2, 3, and then I tell you there's a point 2, 3 that is on the circle. So again, if you can just visualize this situation here, I've given you the center at negative 2, 3, and who cares if it's graphed correctly. And then there's a point on the circle. Call it 2, 3 over here. And I want the equation of the circle. Whoa, we know that the standard form is x minus h squared. This is what you have to have memorized. Plus y minus k squared equals r squared. Got to have that memorized. Well, I need to plug in h, k, and r. Well, I have h and k. It's my center. Here's my h, and here's my k. But I don't have my r. What is that distance? Oh, well, we can use the distance formula. Okay, so I'll write the general distance formula down first. Distance, x2 minus x1 squared plus y2 minus y1 squared. That's all inside of square root. Well, let's write it for our problem. For our problem, to find the radius, we're going to do the x minus h squared plus y minus k squared. Right? Start with your outside point, subtract your center. This is going to give us my radius. So we have x, not x. So we have 2, this is my x and that's my y. 2 minus negative 2 squared, h is negative 2, plus 3 minus 3 squared, all inside a square root. So again, I'm just finding my radius. Find r first. Find r. That's what I'm doing right now, so that I can create my equation. Well, inside here, let's just go to the left. This is 2 plus 2, which is 4, and 4 squared is 16. This is 3 minus 3, which is 0, and 0 squared is 0. So the 0 doesn't matter, it's just the square root of 16, which is 4. My radius is 4. This is my r. So now I have my center at negative 2, 3, and my radius is 4. And now I can create my equation. Okay? And that equation is going to be x minus a negative 2, which is x plus 2 squared, plus y minus 3 squared equals r squared, which is 16. So pay very close attention to this problem. Practice it once or twice. But again, find the radius, then just plug that in with the center into the equation. Alright, so hope this video helps. Again, I would suggest watching the 1 through 3 video again, just to refresh on inscribed angles, central angles, arcs, all that fun stuff. Alright, happy studying. We'll see you on Monday.